which is why I've developed, these more. Hmm. I've been developing like more correct ways of thinking through the math, and then better ways to start helping students understand it, which is, oh, I also really like. Now this is mostly like early algebra, but there is a publication called Nix the Tricks, which is essentially a manifesto of teachers' work that says, like, do not teach students that, like, do not teach students the Pop Goes the Weasel song for the quadratic formula. Like, don't do that. Maybe you should think a little more deeply about the mathematics. What kind of division are we talking about? Hmm. Like arithmetic? Um. Yeah. Like, I don't have any particular sources for myself that I've been going to. Um, I'm curious now, though. I have been going over to like Patrick JMT, Math is Fun, Purple Math. There are a couple of, and Khan Academy. There are a couple of issues that I have with some of their stuff, mostly because they're like trying to get an idea across without necessarily like getting the real deep level um, understanding. It's just kind of like, here's a process, and yeah, that's okay, but it's not really what we're doing. So actually if you were interested in like deep level fundamental arithmetic, you might want to check out. And actually, I should ask you, where are you like elsewhere in in mathematics? Like, what have you formally taken through or informally worked yourself through and think you completely understand? That'd be an interesting question. Oops, wrong one. There we go. Oh, okay. Whew. All right. Yeah, yeah. I wasn't so much worried about understanding of division. If you're here, chances are, but yeah. So I took a class in my junior year that was called Abstract Algebra, which, granted, is probably not where you're going with this, but it is an interesting little course that, like, you, there you go. Well, my dean was in this class, back in his days, And he said day one, his instructor walked in and did, the usual welcome to class. Here's how to do stuff. Here are our online resources. This is where to find things. Make sure you contact each other and get your numbers and whatever. And he said, he did a little bit of a lecture, and he said, in the next day, I want you all to come back and tell me what you've learned, because, your homework is assigned. You're going to be learning this material and then coming back here and reporting what you have learned and basically what you have proved in math. And the beginning stuff was like, yeah, I mean, the one that I did was very much, very much focused on defining what like addition was. And defining like the basis of numbers, things like that. What I'm thinking is you would probably actually want to get teachers' resources. Yeah. You'd probably want to get teachers' resources on some of the early stuff. So, elementary education, if you're really going to dig into like why this stuff works, look into like the Common Core level stuff and really understand why they're doing the things they're doing. I will say Sal Khan does a good job on the Common Core stuff. He has a whole section devoted to Common Core, which are like teaching parents that the way you learned it is not the way your kids are learning it. I mean, like, to really understand division, right, what we're doing essentially is saying, like, you've got a pile of 35 things, you want to split them evenly 3 ways, let's say. And I mean, most of the time we can just do this in our head, but the point is, if you have 35 things over here, yeah, I mean, that's a good way to do it. If it's a decent learning, and the fact that you've gone this far and have been able to really like hone in on things shows that you get what you have a motivation to learn, and it's not just like for a grade, it's now to really get it. Yeah, definitely. I definitely love talking to people about math. That's why I'm here. I mean, that's really what I created the entire channel for, was that I said, like, what am I good at? Because it's not going to just be sitting here playing games, and it's not going to be just making a channel to do whatever. But yeah, like, talking about math is my, and yes, I do have a gaming channel, but yeah. So to understand division, for instance, it would be stuff like, it would be stuff like, we want to split 35 3 ways, so what do? Well, we take essentially like cards off the deck, or, rocks out of a pile or whatever, and start doling them out. So 1, 2, 3. Well, you just gave away 3 of them, so you just subtracted 3. And then 1, 2, 3, well, you've just subtracted another 3. And the point of all of this is that division is really repeated subtraction. And I didn't really learn this until, people started complaining about Common Core. I said, oh, that's what that is. And even our algorithm is steeped in that. Like the original algorithm that we all probably learned, right? 3 divided by 3 is 1. It's not really 1, it's 3 into 30. So this is not this anymore. It's, oops, that. So if you divide 3 into this, it's going to be 10. Nothing left over. And then this is 3 into 5 goes once, and then we subtract 1, 3 off of it, and then you're left with 2, so you get a remainder of 2. Yes. I agree it isolates the group. The other benefit to this, though, is when you start getting into, well, I mean, you've been there already. When you get into like pre-calculus and you've got x squared plus 3x plus 7, and then you're dividing by x minus 1, right? You're essentially doing this algorithm here where you've got separate terms which have different units. So you have our x squared term, you have our x term, and you have our 7, our 1's term. So because they have different place values, that's then how we're actually doing this. And you know, you could write this out in the same division algorithm. We've already, we didn't talk about this on this channel, but you know, my classes have gone through this already. So x times x minus 1 is going to be x squared minus x, and then you're subtracting this, so that's going to add this to that, so it's going to be 4x. Bring this down because we need 2 terms to line it up properly. It's going to be 4x minus 4, and then we're subtracting, so this is going to be a positive 11 plus, oop, where did I, yeah, 4. 11 over x minus 1. Well, in calculus, we ended up learning how to do like partial fractions instead, and saying like, I need to divide out x minus 1's. So what do? I'm going to take my x squared plus 3x plus 7. I'm going to rearrange the first terms into x squared plus, x squared minus x plus 4x minus 4 plus 11. And then this one is x times x minus 1. This is 4 times x minus 1, and then plus 11 on the end. And in my calculus class, our students can do this in practically no time, but they don't even recognize that they just did polynomial long division. You know, it's so far removed from what they're paying attention to. It's just something, it's completely different to them. But, you know, the point here is that when you're doing calculus and you need to integrate x squared plus 3x plus 7 over x minus 1 dx, this becomes way easier when you do all this over here. Yes, sorry. So my students would say like, oh, I need x squared is going to be an x minus 1 if I make this x squared minus x. And then if this is minus x, then it's plus 4x over here. And then they said, well, if I have a plus 4x, I'm going to need a minus 4 to make it x minus 1. So then minus 4 plus 11 is 7. And so they just like instantaneously do it without even paying attention. Oops. That was weird. So then they end up with the integral of, what is that now? Right, x plus 4 plus 11 over x minus 1 dx, which is so much easier. So, I mean, that's difficult. I think it's a representation of an abstract concept. There is a pretty decent documentary on, like, Hannah Fry did a decent documentary on the BBC called what did she call it? It was basically, the question was, is math invented or discovered? And she has a series of like 4 or 5, I think, shows that go on and touch on that topic. So partially right? How do you define a number is kind of along those lines. Is it something we discovered, or is it something that's just invented by humans? Again, the way that I think is that you've got numbers which are constructs or ideas which represent this numerical concept, whatever it might be. So, well, yeah, the question is like, is this actually something fundamental to the universe? Like, is the number one a thing? Like, is it a thing that we discovered, or is it a representation that has come to pass? Like, what's going on? Yeah, and time. I was also interested in physics way back in the day. I got into theoretical astrophysics and read up on, Hawking. I mostly read Stephen Hawking's work. I read a little bit of Neil deGrasse Tyson, but not as much as I probably have listened to him talk about stuff. So I don't know. I think I'm more of the mind that, like, pretty much the entire, when we go beyond our universe by itself, that everything is pretty much like a fractal. That it's just constant bubbling and churning and things rising in the place where, like, in the exact place where our universe is. Something will arise eventually, which will be the universe itself, and it'll just keep, like, repeating itself over and over again. But, I mean, who knows? It's not really. Once we get out past, like, 100 trillion years, it's something like all the energy in the universe is going to start dissipating, and atoms will decay. Anyway. I don't know what's going to happen. I mean, nobody does, but... So... Yeah, that's kind of one of the things that I like. If you look at Futurama... well, the other thing is that time might be inherent to our universe, and the time that we experience is only inherent to this universe, and the time everywhere outside of the universe, it is irrelevant. So... It may be finite within this universe, but it may be that there is no concept of it outside. So yeah, like, how do you represent number? Man, it's been so long since I've done any of this, like, abstract stuff. My abstract algebra book is in my office, which I haven't seen in a year. So the, like, concept of numbers in general, yeah, you're starting to get into pretty deep territory here. Hello, Cherry Dipper, how's it going? So if these are representational numerical concepts, like, where do we go? Like, you could start talking about, like, individual things, whatever they are, is kind of the applied math that we go into. So if you have, like, things, then clearly adding things to other things ends up getting us more things. And whether we do them as, like, rocks or we do them as numbers, it completely makes sense that all of this, this conceptual idea is still going to hold no matter how far we go. I've also done like there's a bunch of puzzles that I come across a lot, which end up like if you add, if I don't know, they'll like stick a couple of symbols together and do like, this star, this is going to get like an up arrow and like, I don't know, triangle, arrow. Anyway. Anyway, yeah, so like I got into puzzles for a while that have, mathematical ideas like this, where they're showing you like some weird symbols, and then you've got like 20 different things that are all right in a row, and you've got to figure out based on all of them what symbols represent what and what they actually equal to, and then at the bottom they give you like a string of symbols, and then that string of symbols ends up being the solution to the puzzle. So you plug it in online or whatever, and it says, congratulations, you've got it right. So sometimes that's a little nuts. Would you be interested to hear what my take is on your problem that you're working on? I don't know if it's worthwhile, but we can give it a shot. Just wanted to see if I had anything else here waiting for me, but I don't. That's fine. Oh man, we're gonna start getting into the Telus Principle now. Yes, something that exists. Sure. Mm-hmm. Okay, sure. Craig, sure. Uh-huh. in my estimation, I don't think infinity itself is an entity. I think it is I mean, knowing what I have seen in mathematics at least, I don't think mathematically infinity is an entity, due to the fact that we don't actually have infinity at any given point. It's a limit. So any particular value is by itself an entity because you will arrive at that exact value. But you can only ever get to infinity by issuing limits. So, like division by 0, for example, is not technically a thing, as much as people might say, sure, why not? There was actually another thing that I was doing in college, which was, I was saying, okay, pretend that your coordinate axes are on a sphere. Somebody else already did this, I found out, way before me, which I'm not surprised. Nothing is new. So then if we count out however far you want, eventually one of the things that you can do is just call this point here infinity. And like all of the negatives, the positives in the y direction, the positives and the negatives in the y direction all end up back at this infinity, so it is like a point, which could very well be an entity if you think of it like that. But then again, you can't actually reach that point, but you know.